Hello, I'm JW. This time I have this LED lamp here, and this was working, but unfortunately it just gave up one day whilst it was actually turned on. It was working and then suddenly stopped working. So I thought we'd have a look inside this. Now this is actually made by Philips, as you can obviously see on the front there. And this was a fairly expensive item as these things go. This was bought a couple of years ago, and it was around sort of £12 at the time. You can still buy these, they're now a bit cheaper, they're around £7 each, but nevertheless a fairly pricey item. And it has been used fairly extensively. I'd estimate it's probably done sort of 4,000, 5,000 hours or something. As I say, it's been in for about 2 years and it's been used for a fairly lengthy time each day. So have a look inside, see what's actually broken, and of course also how this thing is constructed. Now here's the thing, I've already been prying at it to get the lid off, so that's why it's got those marks around there. The top of this is plastic and the body is also plastic, metal bayonet or B22 end on that. That's fairly standard in the UK. Made by Philips there, and on the other side here it's a bit difficult to see, but the rating of this is actually 9.5 watts, and as I say, made in China fairly obviously. And I say this cost around £12 at the time, so they're a bit cheaper now, so we'll see what's actually inside. These are things that are supposed to be rated for sort of 10,000 or 15,000 hours or something. So I'd estimate this has probably done sort of 4,000 or 5,000, but of course it doesn't necessarily mean it's inherently faulty, because of course that 10,000 hour life or whatever is only an average. Now I've actually been prying around this, as you can see on the edge here, and it turns out that this plastic lid is just glued on with some sort of white rubbery type material, so that comes off fairly easily. And inside, so we've got the LEDs there, I've got sort of two sets there, and this is a warm white actual lamp. And it's got a couple of screws there holding it in, and then there's a sort of plastic disc here, which unfortunately has got a bit broke there, and I tried to pry it out. And underneath there you'll see this backing piece is actually metal, and this whole base is actually quite a weighty item. It's not just sort of hollow or anything, it's certainly amount of weight to that. So let's see if we can just undo that and see what's underneath. Now, so this one suddenly failed whilst it was actually turned on. It was working fine, and then suddenly it just went off, and now it doesn't work at all. And it was in a ceiling pendant, so it was sort of hanging up that way, so all the heat was coming up into the top rather than out the front. And these do get fairly hot when in use. I've actually got a number of these in use in this house and in various other locations. And certainly the body is sort of, wouldn't burn you if you touched it, but you wouldn't want to be holding onto it for any length of time, because so it does get to a reasonably high temperature. So just remove those screws, and hopefully then we can remove this plate. Okay, well that's just broken off there, and this is obviously a separate board, and it seems to be sort of tacked or glued down onto this metal substrate. Okay, so it's just sort of glued down with some sort of silicone type material at the edge there. Now let's just see if this circuit board will actually lift off of here. Presumably it's either glued or fixed down with some sort of thermal compound. Okay, there we go, so that just pulls away from there. And yeah, some sort of thermal compound underneath there. It's just directly onto that metal plate, and this appears to be a metal backed PCB as well, so I've got the good thermal connection between the two. And this huge metal bit here is presumably what all of the weight in this is, so this is quite a heavy item. So a little circuit board with the two sets of LEDs there, and just two wires then going down into the base, which I'll have to try and pry open. Now just remove some of the plastic here, and as you can see the whole of the casing is actually metal all the way from the top here down to the actual cap here, and of course that's what's accounting for the substantial weight. So this certainly is not going to be an easy item to open and see what's inside. The top here is just a metal plate, the only holes are for the two screws, and then a small hole where those wires go through into the bottom. And there does seem to be a kind of a gap or seam around the edge here, but again that's not coming open particularly freely, and not entirely clear whether that's put in and then it's fitted onto the back here, or whether it's put in the top and that's sort of crimped closed in some fashion. But nevertheless we'll persevere with it and see if we can get inside. Well, this side material is indeed metal, and it seems to be either, say, crimped or sealed on the top. There doesn't seem to be any way of getting that out, so remove the bottom here, which was basically just the bayonet cap, which is fairly thin metal. And you can see inside here there's a single capacitor there. These are the two leads which were in the bayonet cap there for the power to go in. And we've got a circuit board here, but as you can see it's been conformally coated or something in this black material, so can't actually see anything in there, and whatever this is fairly sort of rubbery in its consistency. You see it does just peel away there with the edge of the knife. So fairly obviously this was designed not to be opened, and they've made every effort in fact to ensure that you can't. So that's basically what we can see at the moment. You can see there's a small inductor possibly down in the bottom there, and that capacitor there. And so the circuit board on its side basically comes all the way down to the bottom where the contacts are. I mean, that's the sort of ring of metal there which was on the side there, and then of course the rest of it literally just came across the top, and the two little contacts there for the two pads on the bottom. Now just remove the circuit board from the rest of the assembly, as I think getting there is going to be next to impossible without actually cutting through this metal with a angle grinder or something, and even then we're not going to get very far because the whole board seems to be sealed in this black gungy resin, and although it's up to the top here, if you look down inside I think they've basically filled the thing with whatever that is, so it's totally potted inside. Obviously Philips don't want to give away any secrets of their what is probably a fairly standard power supply board in there. Quite what the failure is not really clear from this end. It's certainly not the capacitor, or at least if it is, it's not burst open. Although bearing in mind the positioning of that capacitor, that's a fairly poor choice, given the fact that most of these are going to be in ceiling pendants or hanging down. So this of course is right at the top where all of the heat will collect. I mean, it'd probably fine if in a sort of a lamp the other way up, but certainly that way it's going to be the hottest part. And so you can't really see a great deal else down in there, and even the capacitor itself is coated in that black gunge, so pretty much impossible to get inside. Now this is the circuit board which was taken out of the top there, and it only had the two wires here, basically the positive and negative as marked there, and it got these two groups of 12 LEDs. These are warm white of course, for the same warm white as on the actual casing of the thing. It stated a colour temperature of 2700, so that's certainly in the orangey section of the spectrum. Now I can actually see that this thing does actually work, so I've got a power supply here, and I'll just connect up to the negative one over there. Now in theory if we connect here it should illuminate, but unfortunately the power supply I've got here only goes up to about 30 volts, and as we've got all of these in series, that's insufficient to actually get them to illuminate. So what we can actually do is go in at the centre here, which is basically the sort of interconnection between the two halves. So we just touch the thing in here, and you can see we can actually get them to illuminate there. So it's a bit difficult to keep the thing in there on the correct point. There we go. Now that's about 30 volts, and that's a current of actually only 1 milliamp, so pretty much nothing there. And you can see they're already well illuminated in there, and of course we turn up the current, it will get substantially brighter very quickly. That's only 10 milliamps. You can see that's pretty bright already. Now I'll just turn that back down to the minimum again, because if there's no heatsink on this, it's likely to melt fairly quickly. And we can test the other half in the same way, so just again connect the positive on this side, these wires, and then if we put the negative in the middle, of course it should light the other side. And again we'll just adjust the current there, and again we can get those to illuminate like that. And again that's a current of about again 2 milliamps or so there, and again we can turn that up a fair bit. So that's about as bright as we can go with this supply. That's about well 14 milliamps there at about 32 volts. So as you can see, it doesn't take much current for these to become extremely bright. And that's actually the maximum we can get out of this device, because the voltage would have to be increased to enable the others to illuminate. If we go here, that's actually only 10 of them, so we can turn that up a bit more now. 150 milliamps there, and you can see that's pretty much as bright as it probably was when it was in the room there, so we'll just turn that down before it overheats and melts. So that's the Philips LED lamp, and so unfortunately it's going to be next to impossible to get in there, as they appear to have placed the wires and things inside and then basically poured potting compound or something in the back and soldered the cap on and crimped it around the top there. So even if we manage to get in there, we're not going to see anything because it appears to be completely filled with some sort of resinous gunk of some kind, so not much to see there. But fairly obviously the failure is inside here. It's on the actual power supply side, and so it's probably just some zero cost or next to zero cost component that's gone on the bust, and of course no power gets through to the front. But as we saw there, the actual LEDs themselves are still working just fine on that little board there, and say 24 of those just wired in a series there, which is a fairly unusual choice. So you would have thought they would have gone for a single blob on the top with the LEDs directly on the board, but nevertheless they've gone for the single individual ones on this sort of aluminium type PCB. And as I say, they've only got half the lighting. Of course they would all light if you put the correct voltage across the front there, which is going to be in the order of sort of 65 to 70 volts or so to get them at the full brightness. So until next time, thanks for watching.